Lesson 7, Complex Number Representation. Section 7.3, Resistance. The voltage V and the current I in the figure above are time-varying variables, and those in the figure below are complex numbers. Assuming that the current is given by I equals square root 2 IE sine omega t plus theta, or in complex form as I equals IE, times cosine theta plus j sine theta. According to Ohm's law, the voltage V across the resistor R, is obtained as V equals Ri, equals square root 2 Rie sine omega t plus theta. The corresponding complex number is V equals Rie, times cosine theta plus j sine theta. Ohm's law can be reformulated in terms of complex numbers as V equals Ri. Section 7.4, Inductance. If the current I, which is equal to square root 2 IE sine omega t plus theta, flows into the inductor L, then the voltage V is obtained as square root 2 omega LIE, times sine omega t plus theta plus pi over 2. The corresponding current in complex form is, I equals IE times cosine theta plus j sine theta, and the corresponding voltage is, V equals omega LIE, times cosine theta plus pi over 2, plus j sine theta plus pi over 2. This can be converted to j omega LIE, times cosine theta plus j sine theta. Furthermore, by substituting IE, times cosine theta plus j sine theta with I, it can be simply described as j omega Li. Here, omega L is called inductive reactance. Experiment 7.4. Pause the video, and follow the instructions. Measure VDE and VLE, and find the inductive reactance omega L. The answers to experiment 7.4. These are examples of measured waveforms. In A, the frequency f was 10 kHz, and in B, f was 50 kHz. The orange line is the voltage across the inductor L, and the purple line is the voltage across the resistor R. The measured values are listed in this table. This is the graph of inductive reactance omega L. The horizontal axis represents frequency f. The red circles indicate the measured values. Measured means that these values were calculated based on the measured values of VLE and VDE using this equation. Exercise 7.4. This is your homework. This graph is the result of the previous experiment. The nominal value of inductance L was 10 mH. Calculate the nominal values of inductive reactance omega L at the frequencies f equals 10, 20, 30, 40, and 50 kHz. Draw a line to interpolate the nominal values of omega L. Section 7.5, Capacitance. If the current I, which is equal to square root 2 IE sine omega t plus theta, flows into the capacitor C, then the voltage V across the capacitor is derived as shown in this equation. The corresponding current I and the voltage V in complex form can be expressed using these equations. The relationship between the voltage V and the current I is obtained as V equals negative J times 1 over omega C times I. The coefficient negative 1 over omega C is called capacitive reactance. Experiment 7.5. Pause the video, and follow the instructions. Measure VDE and VCE, and find the capacitive reactance negative 1 over omega C. The answers to experiment 7.5. These are examples of measured waveforms. In A, the frequency f was 10 kHz, and in B, f was 50 kHz. The orange line is the voltage across the capacitor C, and the purple line is the voltage across the resistor R. The measured values are listed in this table. This is the graph of capacitive reactance. The red circles are the measured values. The capacitive reactance is inversely proportional to the frequency f. Exercise 7.5. This is your homework. Pause the video, and write the answers. The author of this material is Takeshi Furuhashi, Professor Emeritus, Nagoya University. If you have any questions, please send an email to this address.